So thank you all for attending a special version of the CAGIS virtual seminar. Let me see if I can share my screen. Sorry to keep you waiting. Let's see if this works. There we go. Can you see that all right? So today we're going to be hearing about the topic smart cities and intelligent infrastructure. My name, of course, is Doug Shoemaker, and I'm Director of Research and Outreach at the Center for Applied GIS. And I wanted to take this opportunity for the groups in our cluster to come together and learn a bit more about each other. So I'm going to start with a little presentation. Here we go. So why are we here? So we all know that December last, our new chancellor established an R1 commission and charged it with, amongst other things, identifying core areas of research and scholarly excellence. So what was the hook? This is a quote: research and economic development will launch a new grant program aimed at helping collaborative teams continue to progress towards establishing new institutional research centers or institutes. So that's pretty great. 82 nominations were submitted for phase 1, and just 38 were advanced to phase 2. And the commission clustered complementary nominations. And so we find ourselves together here under the cluster that's called Smart Cities and Intelligent Infrastructure. So what's so important about the idea of smart cities that might require its own institute or center? Well, let me make that argument. I'll start with a little context. You all probably know that the majority of the world's population lives in cities or urban areas, and that trend from rural to urban is expected to continue at least through mid-century. And in the United States, the proportion is already over 80% of the population living in cities, which is surprising to me. And within this context, Mecklenburg County is amongst the fastest growing areas in the entire USA. So what's the big deal about urbanization? Well, urbanization really does present a dilemma. On one hand, urban centers make us richer, smarter, greener, healthier, and happier. According to Ed Glazer, a noted economist out of Harvard. And there's a lot of evidence to point towards that being true. But on the other hand, we also know that cities exhibit intense social and economic inequities, that they cause extensive environmental impacts, and that large populations are critically reliant on infrastructure. So that's a question about how resilient systems are. So smart city is often offered as a solution to some of these downsides to urbanization. But what is a smart city? Well, written short, it's technology-enabled solution making.
Excuse me, Doug.
Yeah.
So Michael and Cynthia mentioned that it seems there's some issues on your screen sharing. Can you fix that?
Yeah, it's kind of minimized here.
Okay, let me try it again. Is that full size?
Yes.
Yep.
Sorry about that.
That's good now.
Wow, I put a lot of time on those slides too. All right. So, you know, the things that we're very familiar with in the themes that we're very familiar with when we talk about smart cities are things like autonomous vehicles, smart energy, smart health, smart living, smart environment, smart society, and adaptation to climate change. And sort of this linking of AI, artificial intelligence, and ICT, information and communication technologies, with big data has led to this fourth industrial revolution that we're in the midst of. And that's really being led in many ways by this idea of smart cities. And so this is not a comprehensive list, but these are some research horizons that I think are rich and out there for us. And the first thing I'd bring you to is this question of how to bring humans into the center of a smart system and thus improve their life. You know, it's one thing to have an app that helps you find parking near your favorite restaurant, but are there ways that we can use automation to reduce disease burden in populations, for example? Smart cities are also about this understanding complex relationships like correlations and cause and effect between physically and digitally connected places. I love this illustration of space bending and the acknowledgement that with our international airport here in Charlotte, we're a lot closer to London than we are to Bangor, Maine. And, you know, most recently, this need to leverage smart to address sustainability issues, such as how can we best adapt to climate change? So another big reason to pursue this is there's a lot of funding and money pouring into this space. And NSF is running smart and connected communities. They also have sustainable urban systems. In the private sector, we're seeing thousands of millions of dollars being poured in from venture capital into smart city research and deployment. And in the Obama administration, we saw a lot of funding opportunities around the idea of smart cities, and we're likely to see those again in the Biden administration. So there's a lot of support that's online now and will be increasingly available as time goes on. So we're going to hear, so there's the overview, and now we're going to hear three quick talks about what our various groups respectively proposed for our R1 nomination. And we're going to start with Hamed Tabki, who's going to talk to us a bit about his work in smart and sustainable cities. Hamed? Oh, let me give you a quick introduction. Hamed is an assistant professor in the Department of Electrical and Computer Engineering. He's the founder and director of the Transformative Computer Systems and Architecture Research Lab, or TSARS. And his research interests include advancing machine learning, deep learning, data analytics to enhance the safety, health, and overall well-being of our communities. He also serves as lead PI on the funded NSF Smart and Connected Communities project here on campus. Take it away, Hamed.
Thank you so much for the introduction. It's all nice to meet you all virtually. I haven't met some of you before, so I appreciate organizing this event. So I'm going to share my screen. Hopefully you all are able to see my slides. Please let me know if it's not the case. Okay. So today, I feel that this is a good opportunity for me to present the smart connected project that we are doing. And we are in a third year of the project. It's going to be a 5 years effort, and the project awarded almost 3 years ago. And I haven't had a chance to present this project for broader colleagues at UNC Charlotte who are interested in smart connected community research and smart cities. So I'm presenting this research on behalf of a larger team that we have, Dr. Shannon Reed from Criminal Justice, Dr. Ravindran in ECE, Doug Shoemaker that he just organized this event today, and Dr. Srinivas Pulagurta from Transportation Engineering. Also, we have community partners, including, CMPD, Charlotte Mecklenburg Police Department, and City of Charlotte Sustainability Office. So the overall aim of this project is to see how we can bring real-time artificial intelligence and computer vision to address some community problems, particularly focusing on the public safety aspects. We know it's a controversial issue, and we had a George Floyd case last year, and there are more needs for using AI to reduce human biases when it comes to the public safety. But overall, we have a broader vision and bigger vision in this project that NSF is also aware of that, and that's why they funded us, is exploring opportunities to bring privacy-aware responsible AI for broad range of smart cities applications. Okay, so I guess I kind of explained the project vision, but this is the picture we always use for introducing your figure or project and or collaboration ecosystem. But the aim here, and we do have a big community engagement piece, is to bring the law enforcement and communities together to design a solution that can, as I mentioned, can address the public safety concerns and crimes in our communities, while at the same time addressing the privacy concerns, racial profiling concerns, and hopefully remove some biases that we have in our system. And ideally also we can do a better job in our communities safer and more secure. So in general, when we talk about AI and machine learning, our aim is to move from reactive systems to proactive systems. So rather than waiting to something happen, our aim is to build a prediction models and detection models that proactively monitor the system and come with actionable insights. And this is our aim here, to see how we can use the cameras that already we have in our communities. And just to tell you all, we have plenty of cameras in City of Charlotte. They are monitoring most of the activities, but they are really passive. They are not active. They are not leveraging any machine learning or AI or ML. So our aim is to how we can use the sensors, cameras, other sensors to understand what's happening in our community in a very privacy-preserving fashion, making sure that we are protecting the PIIs, but at the same time, we can provide actionable insights for the decision makers, and as well as informing communities and neighborhoods on a spot about events that are happening. I guess I am going ahead of my slides, but here basically, these are our use-inspired research. Privacy is the key. So the center of our algorithmic and system design research is privacy, and that's what I really enjoy to do. I don't see myself as just a computer engineer or scientist that just try to build the next cool algorithm. We are thinking, okay, how we can build something that is deployable, so we can really integrate it to our infrastructure, existing legacy infrastructure. But at the same time, we can also address the concerns. One important one is privacy and ethics also, AI fairness, ethical AI. These are all very interesting topics that computer engineers, scientists need to work with social scientists, public policymakers to come with a really clever solution. Transparency, what kind of feedback mechanisms? Is it a mobile app? Is it a dashboard? What kind of notification we want to provide? Who has access to the data? Where do we store the data? What are the data governance policy? We try to also address those in context of this project, but we're not trying to come with new documents or regulations. We are trying to address these elements in the design. So how we can have a more transparent design, how we can just make sure that we are not saving or storing PII information, how we can make sure that all of the information has been highly encoded, and they are just providing insights about the activities that are happening without revealing the race or gender or identity of individuals. So basically moving from this centralized cloud processing to something more decentralized that can do processing where the data and people are. And obviously this lead to fundamental research both on the algorithm side, which in this case, I'm very passionate about computer vision, that how we can do person re-identification, behavioral analysis, action detection, next to the cameras, right? So we can think about public safety, transportation safety. In social science, I remember we wrote a proposal last year. We didn't get funded. Understand even homelessness, and what are the homeless behaviors, and overall, what are the access to the resources. So all this information we can really understand really micro level, but we need to design new algorithm to make them deployable. And also system infrastructure. So we are familiar with IoT, in Internet of Things and cloud computing. And we also seeing edge computing, which is against cloud computing, how we can push the computation next to the sensors. So what are the innovative system infrastructure that we can come up to address and enable future smart cities applications? So, by the way, feel free to interrupt me anytime if you have questions. I see something in the chat bar. Oh, PII, yes, are personally identifiable information. Thank you so much, Doc, for mentioning that. So where we are, well, I can say the first year of the project, we moved very aggressively. We did extensive community engagements with CPCC, even CMPD, and other neighborhoods. We showed some live demos of the technology. Due to the COVID, we cannot push the community engagement that much, in-person community engagement, But on the technology side, I mean, we have done significant progress, and the technology has been also patented or provisional patent protected, and now we're going for a full patent. That the promise is that how we can provide this privacy aware person detection, re-identification, action detection, activity detection, and segmentation all on the edge without using PII information. And when I say PII, it means that we are not doing facial recognition. We are not using the person face to re-identify them. We're just looking at their behaviors and try to uniquely identify or re-identify them across multiple cameras without knowing who they are, and then try to extract the higher level actions and semantics out of that. And this is good for, let's say, when you want to do anomaly detection, or we present this work last year in a Smart Connect conference, and we had a lot of interest from social scientists. They were interested to understand human group activities or activities in different environments. I know architects are interested to see how humans are using the space. The transportation engineers are interested in the mobility and demand responsive transit. So the core technology that we have developed, we can envision, or even a smart house, can be used for different applications. So we were very mindful to make sure that we are building a platform, a generic platform that can be used as a core technology driver to enable many broader smart city applications. And just mentioning here on the left side, so this is the system we built, is that you have the cameras, you have edge nodes, and you do the deep learning on the edge nodes, and you have an edge server, which is again physically located in the physical environment, if it is city or it is a community college or a hospital, and then we establish a database, and then we only use cloud or let's say AWS when we just want to send notification to responsible personnel, but nothing has been stored on the cloud. So you really don't see a cloud here. Basically, we just do the entire processing in the local physical environment. So basically, this is provide additional assurances that nobody gonna monetize the data, or we're fully protecting the privacy. And at the same time, we generally don't store the videos. We just store the important information and activities. At the same time, we de-identify them on the spot in real time. As I mentioned, technical development algorithm side, one of the key factors that I kind of position my research as well on the algorithm side is we are not interested in optimizing one single algorithm or application. Our aim is to build an ensemble of algorithms. Think about like different algorithms as a different APIs that people can use and put them together to enable different functionality in context of a smart city. So if you look at it, we have segmentation, human segmentation, environment segmentation, human key point extraction, which basically we are extracting the skeleton that can give us ideas about the gates or other micromobilities, and then basic object detection, human re-identification. So traditionally, and if we get the AI algorithm community, people often study and optimize them in isolation. But in the real world scenario, we need to work, and we need all of them. So we need to run ensemble of algorithms. And if we start to run all of them together, it's really impossible to run them in real time and privacy neutral fashion. So we basically build this computer vision pipeline. We call it end-to-end vision pipeline that basically take care of this ensemble of algorithms and make sure that we have a fully end-to-end running system integrated as a literally a pipeline. Each one works on the output of the next previous one. So it's a very producer consumer fashion model. And what we deliver finally is those actionable insights, but with respect to that context, if it is public safety, transportation, or health. And similarly on the system side, we are basically, I apologize, the quality of the image, this image is not the best, but so we are building also this system infrastructure. So okay, you have cool algorithms, you can run them real time, but how can I really deploy them in a real world smart city environment? How do you notify the users? Where is your IoT infrastructure? What are the mobile apps? Where do they run? How do you notify the responsible personnel? So I just show you an abstract idea here that again, we have a local database and it just captures all the IDs, AI activities that are happening on the edge nodes and then store them. And we just, let's say in this case, we have integrated already the platform on AWS. We use Lambda function in AWS to just, as a gateway, to just get to the end user. But AWS or any cloud provider as a middleman doesn't have any knowledge or insight about the information we are transferring or doesn't have access to the actual data. So in contrast to mainstream work that they get the data from the sensor and they push it to the cloud and do the processing on the cloud, we establish everything on the edge, on the physical environment, we do processing there, we have a full control of the data. We just use the cloud to push the notification to the end user. So doing a smart city research is not easy, especially if you're working in public safety space. It's tough, it's difficult, and we need to build trust. And this project has evolved a lot. I mean, sometimes I look at myself 3 years ago and I see how ambitious, or better to say naive, I was in some of my ideas. When you start to talk to different stakeholders and understand their challenges and their requirements, and often they don't want to take a risk because the first job of a city official or is to make sure that he or she's not doing anything that put her into trouble. So they are playing very safe, and we need to make sure that we listen to them and we understand their concerns, and also educate them about our technology. But over time, we realized that a real world testbed is a must. People like to see a real world demo. We cannot just talk about abstract. So we had some contract agreement with CPCC, and I think this is one of the first that we have really involving community colleges with the NSF research, with the research university to co-create something which has research merits, but at the same time has a community engagement piece. So we are in process of building our first real world testbed at CPCC campus. The other reason that we use CPCC because they have a training camp for law enforcement officers. So this is very interesting to see how that would be integrated with the existing training camp that they have. We already bought the equipment. We renovate the environment. We established the lab. Then we are moving fairly fast on that part. The other lesson we learned is that it's hard to tell them that, hey, existing infrastructure is bad. You need to just demolish it and build something new. So we try to change our algorithm design and our system solutions to make sure that it can run, on legacy hardware and legacy infrastructure. And at the same time, I guess you see here that we have done extensive community engagement. We established right before COVID. We organized a regional summit with the title of Technology and AI for Social Good. Well, Doug Shoemaker, who is here, helped me a lot, and we kind of co-organized the summit together. And I think it was very successful. We had people from city, we had people from local law enforcement officers, different stakeholders, general public, business owners. And you see here, we show a real-time live demo for technology so people could see what we are talking. And I feel that was essential for public awareness and even educating the general public about what kind of AI we are talking about. I was very proud of that, I should say that. And I wish we could do it last year, but unfortunately because of COVID. But I hope that we can do another one like next year, hopefully.
Very good, very good.
I guess I'm talking too much. I'm almost done.
Yes, Cynthia has a great question, but if it's
sure.
with your permission, I'd like to hold it until the end of the session because we got to fit some more in. Is that okay? Thanks. So next, we're going to hear from Dr. Eric Delmelle about geospatial analytics for healthy and resilient urban systems. Dr. Delmelle is associate professor here in geography and earth sciences. And his research focuses on answering fundamental epidemiological questions where spatial and spatiotemporal methodologies are critical. And he does this using robust geocomputational methodologies and visualization techniques to detect time-space patterns. Very good. Take it away, Eric.
Yeah, thank you, Doug, for the introduction. I just want to check if you can hear me well.
You can, beautiful, loud and clear.
And the presentation should be shared. I've removed the video because of limited internet bandwidth with everyone who is using internet in the house here. So I will try to keep it short and give you a little bit of overview on this initiative called Geospatial Analytics for healthy and resilient urban system that we put together as a response to this R1 commission. So I'm Eric Delmelle. I'm, as Doug mentioned, a faculty in geography and earth science. Part of these efforts, of course, is Dr. Wenwu Tang, who is the director of the Center for Applied Geographic Information Science and also a colleague in my department. Laurie Thomas, I will talk about her a little bit later in the presentation, who, as you know, work at the Urban Institute as the interim director, among many other things. And also, I'd like to thank Doug Shoemaker for putting this together, and also my chair, Deborah Thomas, who also was instrumental in putting this response to the R1 Commission. So first, I will give a little bit of background on the importance of harnessing big data, and then I will go over our response to the R1 Commission through this center, for healthy and resilient urban systems. Okay, so here, okay, perfect. So in recent years, the amount of geographic data has increased. Of course, we have seen this in the previous presentation. It provides extraordinary opportunities for place-based, evidence-driven decision-making that capture the complexity of urban system. So essentially, we have this massive increase of data from different sensors and so on that is becoming available. And as an example of this increase in the volume and the velocity and so on of data, 90% of all data in existence today was generated in the 2 years prior to 2018. And just to give you another perspective, an estimated 80% of this data are geographic and location enabled. So we see that as the year passes by, the amount of data that is generated just keeps on increasing. And many of these data sets are of geographic nature and of course of temporal nature. So transforming big data and geospatial big data. I really want to insist on the geospatial into information poses immense challenges in regards to efficient data management. Of course, this really large amount of data, information extractions, spatial data mining and analytics, as well visualization. So all of this, you know, that would be a sort of a dream GIS if we could do all of this, of course. It's important to remember in this context that we need to capture patterns of physical, social, and built environment. And in order to do that, we need to have integrated or fused data set. We need to have domain knowledge of people can actually understand this data set and the information that is, or knowledge that is generated from this data set. And also new data mining technology or novel data mining technology. And geographers themselves cannot do that. So we really need a strong collaborative group of individuals who can work together. So researchers, like many of us here on this call, need appropriate and secure access to multi-scalar data, both coarse to fine, so we can think about fine data at the individual level and coarse, maybe aggregated level, to inform crucial time-sensitive adaptation necessary for healthy, resilient, and equitable urban areas. And so just an example of COVID-19, for instance, of course, if we had individual data on cases, death, and so on, that would have been much better in terms of knowledge, but it also raised an issue of privacy. And so how do we deal with data that is also, that needs to be protected? And so that is an important component of our response to the R1 Commission. So the main question that is, that was the driver of our proposal was how we could harness the vast amount of existing and emerging geospatial, and by geospatial, I mean geographic, of course, big data to inform and guide sustainable urbanization, okay? So what we need are ways to bring big data to knowledge domains associated with sustainable urbanization. And thus we need to bridge disciplinary silos. As I mentioned, just as geographers, for instance, we cannot address those questions by ourselves. And so we also, because some of the data may be sensitive, we need secure system that can also contextualize the data as to when and where, and make it accessible to scholars and protect sensitive information often associated with social data. Now, of course, it's very evident that if we were using, say, health-related data, that we need to protect HIPAA. So that does make sense, but there are also other data sets that may not directly be health-related and that we still want to protect. So in response to this, we developed the geospatial analytics for healthy and resilient urban system. And you can think about it as a research enterprise in a way. And I am going now to take a few minutes and unpack what this diagram represents. But what you will notice on this graph that I'll come back to later, you can think about this as an opportunity to expand and transform endeavors in data curation from the Urban Institute, Geo Analytics, with linking them with cyber infrastructure. So you have these sort of two pillars, Urban Institute and Geo Analytics. I'll go over those in a second. And what links them together is this idea of cyber infrastructure, especially when we have to deal with massive data set. So let's first talk about the data curation side. The Urban Institute is well known in the region for delivering non-partisan information to those seeking solution to the social, economic, and environmental challenges that are facing our communities. A great example that many of you probably know about is the Quality of Life Explorer, that is a map-based interactive website that let people search for a range of information according to where they live and work. And what is interesting is that this initiative has been updated over the years, and it was not just a one-time initiative, but it's been updated. Its interim director is Laurie Thomas, who also oversees the Institute for Social Capital. That is also something we'll talk about in a second. The Institute for Social Capital maintains a huge database of social data, and a few examples of providers of this data are the Charlotte-Mecklenburg School, CMS, Mecklenburg County Department of Social Services, Mecklenburg County Sheriff's Office, homeless management information system, and cardinal innovation healthcare. So you see that many of the examples that I just provide you are sensitive data. And because of this sensitive nature of the data, access to has been limited and often lacks key contextualization needed to understand connection and correlation within an urban environment. Now, the other players that is very important is on the Geo Analytics side, of course. And there we have one main player here, which is the Center for Applied Geographic Information Science, which is an interdisciplinary research centers that use advanced space-time theories, methods, and technology to address pressing multi-scale resource sustainability issues. It's housed in the Geography and Earth Science Department with the director Wenwu Tang and Director of Research and Outreach, Douglas Shoemaker, who has facilitated this, this meeting today. Yes, and I'm an associate faculty. Let's not spend too much time on that, on me. Part of also is the SHARP. So the SHARP is the Charlotte Action Research Project. And we feel that this is a very important player, okay, because SHARP forged partnership between UNC Charlotte and marginalized communities in Charlotte. It integrates both teaching, research, and action to work towards a larger agenda of social justice, advocacy, and sustainable neighborhoods. And the director of the center is Dr. Colleen Hammelman, also in geography and earth science. And the last piece of the puzzle in this geoanalytics pillar is the visualization center. It's called the Rybarski Center for Visual Analytics. This is co-directed by Zach Wartel and Dan Jennings. And Dr. Wartel is an associate professor in computer science with a research that focuses on advanced user interface, including virtual and mixed reality interface and multi-touch displays. They've already been a very strong partner of the Center for Applied GIS, and they have collaborated a lot in the past as well. So we are going to connect these two groups, the data curation and the geoanalytics, with this cyber infrastructure. So cyber infrastructure, as I mentioned a little bit earlier, are integrated hardware and software systems that create opportunities for qualified researchers to access specific and sometimes sensitive, such as health data, contextualized by time and place in a secure environment with relevant tools. When we link these, we conceptualize a big tent, if you want, okay, or an umbrella rather, research enterprise that is called the Geospatial Analytics for Healthy and Resilient Urban System. Tucked under this umbrella are three broad domains: the environment, the society, and urban systems that, when connected, can provide a synergistic understanding of what makes a city healthy and resilient. So for this proposal that we put together as a response to the R1, we identify 5 interdisciplinary research nodes enabled by our research enterprise. And each node is populated by a team of researchers with over 80 high impact academics on board. So there are a lot of people, of course, and researchers who sign up for these initiatives. The first one is urban change, where we look at neighborhood transition, urban-rural connections, and growth modeling. The second is environmental quality, water, air, and soil. The third one is on society, on health and well-being. We're looking at infectious disease, health equity, chronic disease, mental health. The fourth one is on climate change and disaster, where we are interested in adaptation and mitigation and monitoring. And the fifth one is on smart and connected cities, something that was discussed a little bit in the previous presentation, where we focus on sustainability, resilience, AI, automation, and efficiency. So I hope that this gave you a little bit of a background of the importance, of course, of data, but especially how we propose to tackle this pressing need of data with different actors under the umbrella of the Geospatial Analytics Center for Healthy and Resilient Urban Systems. And so, Doug, I will turn it over to you. And I mentioned that I was trying to keep it short. So I hope that was okay.
It was perfect. Thank you so much. And again, we'll hold any questions until the end of our presentation. And our final presentation is with Dr. Kyung Hee Kim. and it's entitled Transformative Architecture Technology Towards a Carbon Neutral, Healthy Built Environment. Dr. Kim is an associate professor in architecture, and she's also director of the Integrated Design Research Lab, or IDRL. And she's interested, I love this, in performance-based design, innovative building systems, and as a way to improve the sustainability of the built environment. Thank you so much. Anxious to hear this.
Thank you, Doug, for the good introduction. I'm going to share my slides. All right, so thank you again for inviting me to share our research lab is doing, and also thank you for joining our presentation. So I'd like to probably my slides today is slightly different from other two presenters. As a background information for myself, I'm also a practicing licensed architect. I have around 15 years industry experience in the United States. So it is a natural response that somehow I want to transfer the lab project into the marketplace. And that is how the transformative architecture technology name became. So I will focusing on the technology transfer activities that is happening right now for the biochromic windows towards the carbon neutrality. Matt Perro of the biological science, he has been a key research member for these efforts. And Dr. Ibong is also working on another project that is aiming to do the technology transfer built around the building integrated photovoltaic systems. And then my colleague at the School of Architecture, the Professor Liz McCormick, is also on board in advancing the energy efficiency and sustainability in the built environment. And Dr. George Marquis also helping us on the evaluating how the sustainable architecture technology impact human performance. So I'd like to start by addressing the problems associated with the built environment. First of all, buildings are the primary contributor of the energy consumption and pollution emissions, impacting both the human health and ecosystem. And especially the buildings built prior to the 1980s, which has a lot of low-performing old windows. They are responsible for more than half of the building energy consumption from heating, cooling, and lighting load in the United States. Besides the energy efficiency and also the pollutant emission perspective, there is also the economic prosperity associated with what we are doing. So energy efficient window retrofitting has a market size of $10 billion in 2021 and is projected to grow to $20 billion in 2030. So this is a solution. So what we are trying to do is that we like to integrate high-performing microalgae biological systems within the window assembly to retrofit low-performing windows. It aims to provide the good insulation and also dynamic shading efficiency depending on the seasons and sun intensity, while also maximizing the year-round daylighting penetration and allow for users to view out. The end product of this the system, which will become the microalgae biomass, can turn into value-added products such as the human foods, or the foods for literally all of the life, including the aquaculture, plants, and also we are investigating the way to convert them into biofuels and electricity as well. So for those who are not familiar with the nature of the research happening in architecture field is that the architecture is the synthesis of the humanity and science. So we are not truly hardcore engineering or science, but we are dealing with both spectrums. And then, of course, this technology is more towards the science and under the design science realm. regarding the research natures, architecture also do cover basic research and also the transformative research. And then right now, the project, the nature in terms of the architecture, the research will be the applied research towards the transformation of the research into the marketplace, tech transfer. So these are the key like research entities for the biochromic windows. So recently I launched the university spin-off and then launched the EcoClosure to commercialize this technology, collaborating with the professors and scientists on campus and also the practice as well. We've been working with the building industries, architects, building owners, contractors, etc., along with the national, the federal research labs as well to address validate the value propositions. In this case, the energy efficiency and decarbonations, and then towards the commercial viability of the technology. So why microalgae? So in 1950s, microalgae was promoted as a food source. And then in 1970s, in the aerospace industry, consider the microalgae as part of the bio-regenerative life supporting system. They can do the air revitalization, waste treatment, and food production in the spaceship. In 2010, the Cruella was transported to the International Space Station, and then verified its feasibility of the BLSS. And also the timeline of this research has been more than a decade. So since I joined the UNC Charlotte in 2010, Matt and I wrote a small grant, and that is the beginning of this research project, the journey. And then we were able to secure institutional grants and then the grants from the professional organization. Last year, we secured the NSF STTR grant, allows to conduct the one-to-one prototype and the performance verifications. Next year, March, the book about the design engineering principle about the microalgae building closures will be published by the Routledge. These are the 5 typologies that are under patent pending, depending on the material techniques. In the geometry and configurations, they are inflated, stranded, woven, divided, and suspended. The suspended one is the one that we received the fund from the National Science Foundation and was able to do the mock-up, which is now installed in the architecture building. So these are the quick video how the systems will be assembled. So again, the suspended system has a multi-layers of the bioreactor that can grow different types of strains of the microalgae. The young algae will be fed, gravity feed from the top, and then the grown algae will be grown at the bottom. And then the system also allow to be installed, assembled in a factory and shipped a final product to the site and they install on building as a building facades or building enclosures, or the growing devices and valves, etc., will be housed within the window frames. And then again, the young algae will be fed from the top. And then to grow the microalgae, the room air, which has a higher carbon dioxide intensity, will be fed into the system. The oxygen as a byproduct of this system will be utilized to improve the indoor air quality. And the biomass either could be processed on site or can be shipped to the refinery site. So this is the zoom in view, close-up view of the mock-up installed in the stores building. So again, the value propositions related to the energy efficiency and then the improving the indoor air quality, which is related to the carbon reduction, is very important for us. So the way we are trying to do is that we like to automatically regulate the intensity, the density, and the color of the microalgae. depending on the sunlight intensity and carbon dioxide levels. Only a fraction of the solar energy will be utilized by the microalgae for their photosynthesis, and majority of the sun energy will be stored in the system as a heat energy. And we are trying to also reclaim that the stored energy to either heat the space as a hydronic heating system or heat the domestic hot water. So these are the 6 different strains. We chose these final strains based on it's easy to grow them and also the value of their final product as a biomass. We are also instrument many environmental and performance sensors to monitor its performance as well. And then the Aidan Brown at the engineering department helped us on the automatic controls of the microalgae circulations as well. At the bottom, images show that. I just want to quickly go through the prototyping development. We spent really almost half the year last year to went through the making test simulations, again, make again. So these this is like snapshots of those lengthy process, but in the end we were able to put them into a mock-up. So the the modular like a construction also allow us to easy fast installation depending on the size of the window and also the size of the building as well. And then this is the showing that the system also give us a quick visual loop, a feedback loop, how much the carbon has been sequestered by looking at the density of the algae, and also the algae density will be changing depending on the sun intensity and also the carbon dioxide intensity as well. We also ran extensive lab experiments that are related to the energy efficiency. So we calculate the coefficient, visible light transmittance, and so on. We also carry out the thermal cycling tests. So depending on the extreme outdoor condition, the system is able to operate as we design. In the meantime, again, the performance-based means that the data, the evidence guide us to revise the system. So along we grow the microalgae within the system, we also measure the growth for different strains. So these are the graphs that tells us which strains outperform the others. So in conclusion about the value propositions, one commercial building with the microalgae windows as an example can power 300 homes annually because it is reducing the energy consumption to operate the building. And because of that, also it removes 6,000 tons of carbon dioxide annually from the energy savings. In addition to that, because of the photosynthesis of the microalgae, result in the additional 7,000 tons of decarbonation annually. So that is the more building energy performance and decarbonation potentials. We are also interested in how this technology impacts the human perception and human performance as well. And algae carries inherent color. So we are looking at whether the color and intensity of the microalgae cell affect human performance as well. We are also using both in on-site testing setup as well as the virtual reality to evaluate their impact on human performance. So these are the collaborators last year for the NSF research activities, and thank you for your attention.
Oh, thank you. That was so interesting. Well, we have a few minutes left. We've got a couple of questions that have come in. Does anybody want to start with an articulated question? If not, Hamed, if you're still there, Cynthia asked about is monitoring or recording or quantifying gestures. Can't gestures be considered as PII? I mean, they're maybe even could be identified as well as
to identify people. They have to be characteristic enough that you can use them to identify people, and you would think that they would just be subject to the same restrictions as all the other stuff that we have to be careful about.
Sure. Yeah, that's a great question, and we receive that a lot. So I just want to clarify, when we say we re-identify them, I don't mean that if I see Cynthia today, I will remember her tomorrow. So we are talking about the short term.
Okay.
So we are talking about
the same body that you
body
saw.
across different cameras. That's it. And
Okay.
for that, we use a concept generative adversarial network that everything is so encoded, even I don't know what they are using. But basically, they just detect that based on pixel distribution, movements, and the gates. I'm just trying to provide some examples that what that deep learning in hidden layer is learning, but that's going to forget it as well. So it's just going to remember, oh, the person that is walking in this camera and move from this geometry is the same person that show up in the other camera. So it has a very short memory in general, and everything going to be destroyed over time.
I think that's the key here is if you store, I mean, it has the capability, if it was stored, to then re-identify them the next day or 3 years later. But that's how you keep the PII.
Yeah, we don't
short term, and it's not out of the local system.
Yes, you get it. You got it correctly, right?
So Hamed,
it's a tricky balance.
Well, Hamed, you didn't throw a lot of light on this idea of locating the AI on the edge. So yes. it doesn't necessarily even have to report back. It can just make decisions autonomously.
We don't want to ask AI to make decisions. Sorry for interrupting you. I said actionable insights. Mm-hmm. We want to have AI to give us actionable insights. If it is about the public safety, healthcare, transportation, without knowing really who is doing what. Basically, it's an attention mechanism. But go ahead.
Yeah, and so that we don't really need to record and archive massive data. We can only save the bits which trip some threshold, say.
That's absolutely correct. Yes, that's the whole idea of the project.
But I would add that we should be able to archive the data, not identify individuals. I'm looking at it more from the transportation side. And obviously, you just don't want to detect, let's say, objects, whether it's pedestrian or vehicle. You want to identify, let's say, their actions, patterns. For example, if somebody is looking to the left or right, I mean, before crossing the street, to me, that's very important because that tells me if they're kind of focusing on traffic, they're making an eye contact with the driver. Is it like an unsafe situation? I mean, we want to be able to predict what's going to lead to safe and unsafe situations. So archiving to me is important, but again, it doesn't have to be the specific individual like you're talking about, like a person looked to the left and right today, did he look to the left and right like 10 days later? I mean, to me, I'm not worried about that specific individual, but I want the data because
yeah, this is very correct, and we can provide that data and insight. So what we are talking about, I think we need to identify what type of data we are talking about. So the data that I'm talking about is the micro movements, but obviously we can capture those and build, abstraction on top of that data and provide something that, let's say, perhaps is important for transportation. Am I breaking? I feel my internet is not.
No, you just
very
came
stable.
Back. Thank you so much.
Hello.
I realize that that we're past it's 2:00 right now, and so please feel free to log off if needed. But are there more questions? I had two, and one's for Dr. Kim. And I was wondering if you had ever looked at. Obviously, you have these pathways to commercialization that will allow you to take your idea and scale it, and it's built modular. You can, of course, see how all that would work beautifully. Do you have any idea about how you'd have to deploy it in order to more to sort of change the climate needle to maybe, for that commercial building that's powering 300 homes, how many buildings like that do you have to have a net zero city?
That's a great question. I think I am taking the sometimes bottom up and also top down. So meaning that I know that I see the building surface as an infrastructure to receive this technology. But also in the meantime, I need to figure out nitty-gritty details and operations, cost and so on. So if we are asking how many cities with microalgae can entirely decarbonize anthropogenic emissions, I do not know, but that's something I've been looking into. But I think I am like sharing the same perspective in that, to me, the city is infrastructure as a carbon sink using my technology.
Oh, thank you so much. That's so interesting. And I'll have one final question from myself for the group, which is, the word on the street is this might make it to phase 3, whatever phase 3 is. And I wanted to ask the PIs if there was one thing that you could name that would help you succeed, make stronger proposals, carry good research out, build a lasting, sustainable program here at the University in Charlotte, what would it be? So what's the one thing that would make a difference in terms of support?
Well, I can go for that. I asked for that a couple of years ago, and due to the COVID, we couldn't follow up. I think there is a need for a smart city testbed in city of Charlotte. I wish we could have one block of uptown or near uptown. Then saying that, okay, this is the smart city testbed. Let's use this block to explore smart cities ideas. And I know many universities have in New York, Bronx, you see many NSF a smart city proposal using that area, Cosmos. And I, as a PI, had so much struggle to push my technology in a real world scenarios because we don't have something like that in Charlotte.
Gotcha. So sort of durable relationships with the city or some municipality nearby where we could have this vetted test bed to try these things out, to run demos, to get how people interact. Do people like it or not?
Exactly. And this is going to be such an attractive, solution for bringing more federal and state money to the city of Charlotte and UNC Charlotte, for sure.
That's great. Thank you.
Anyone? Hey, can I just say that JW Clay Station would be great for that, and that block around there, because we have the university and the university city partners that, Srinivas and I are working on something else with.
I actually live next to that area. I would love to see that, if that can happen.
I would echo with what you both said. I think the plan, again, as Doug mentioned, is to see if we could set up a test bed in the university city area. Ideally, if we could have multiple test beds, that would be good. But again, just to add, there are, let's say, some agencies that are very proactive, kind of helpful. There are others, let's not get into the names, but I know, for example, we were able to get like some data from City of Concord, and we were able to use that video data to kind of process, like very similar to what Hamid said. I mean, more from pedestrian safety perspective. So, but again, having a test bed where we could kind of install whatever technology or test whatever, let's say, applications that we are developing, I think that would be perfect. And hopefully sometime soon.
It's getting already late. I hope that we really do action on that, regardless of this.
Yeah, I totally agree with you. We should have had it like by now, but
well, the city created the North End Smart District and then sort of dropped it when they got rid of their sustainability director, and so it's laying out there unused. Dr. Kim, any ideas about if you could name one thing, what it might be?
Yeah, so to me, the test bed is a great idea, but to me, when it comes to the commercialization and want to recruit early adopters, what they ask is that, can you show me the track record of the real world applications? Because this is a new technology. And then I asked them back, how many do you want to see? And then what I got is that they want to see minimum 5 installations to me. So, to me, what I like to have as a university research infrastructure is the community outreach officers. I know, Doug, you introduced the urban farming folks. I need those kind of resources such that, that I can reach out to the community who can get benefit from what I'm doing. And in the meantime, I can fulfill my needs about the real world applications.
I'll take an algae window in my house.
Yeah.
I would totally do that if it was feasible. So especially the algae window is actually very inspiring. So you guys don't all know me very well. I'm Cynthia Gibbous. Why I am here is I am engaged in pandemic monitoring in our local built environment. And so what we're equipped to do is a lot of monitoring and information collection, but we're not so equipped then to translate it into a usable system that could be deployed. Like, we need like biological systems engineers. We need to, people who are going to say, all right, well, we have this detection system. Now we're going to turn it into a self-sustaining situation somehow. That's actually inspired by a recent NSF call that came out that we looked at, and we were like, do we really need to have somebody developing biological sensors for this, as well as just the monitoring capacity and models? So that's what I've been thinking about lately, is like, I would like to see more people like this on campus.
Fantastic.
So Dr. Shoemaker, I think looks like to kind of follow up, if I were to look at it, closing the loop seems to be the most important aspect here. Like demonstrating the applicability of, let's say, the technology that are being developed, or whether it's through the test bed or whatever, right? Working with the practitioners, I think, how could we do that better? That's the most important question, I think. That may be different.
Fantastic. Well, that's useful information, and I'll make sure that Rick Tankersley gets that feedback. Not that I have any special connections or anything. On that note, I don't have really any closing remarks, but I would like to thank you all so much for taking your time to put those presentations together. And I leave you with this sentiment of onward and upward. So, thank you.
Thank you for coordinating and taking the initiative to set it up.